Hello and welcome to this session. This is Bhaskar Napte from Pharma Growth Hub. And in today's discussion, we will try to understand how one can convert a flow rate into a linear velocity. And this conversion is mostly applicable in case of a gas chromatography if you are using a capillary column. So let us understand the definition of a linear velocity. So it is the distance traveled by a carrier gas as we are talking about gas chromatography. So the carrier gas is a mobile phase. So the mobile phase will be traveling through the column. Hence the distance traveled by the carrier gas in the unit of centimeter along with the column in 1 second. So if this is the measurement units of a carrier gas distance traveled and the time measurement, the unit of linear velocity is going to be a centimeter per second. And what is required for calculation of the linear velocity then? We need to understand the flow rate, the first, and the second one. We need to have the value of inner diameter of the capillary column. And as we said, the unit in this case for linear velocity is going to be a centimeter per second because the distance traveled is measured in centimeter and the time measured in the second. So you can have the different unit for linear velocity like maybe meter per minute. In case if the distance travel is in meter and time measured in the minute. But in this presentation, we will consider distance traveled in centimeter and unit of time in time required in the seconds. So here is the core calculation formula for linear velocity in centimeter per second. What is that? It is nothing but the flow rate in ml per minute divided by the cross-sectional area of the column. So the column is nothing but the hollow cylinder, and one can calculate this cross-sectional area of the column if you know the diameter of the column. So we'll talk about the calculation of A also, which is cross-sectional area. The first, let us convert this minute into a second. So how one can convert this minute into a second? It's very simple, right? 1 minute is equal to 60 seconds, right? So divided by 60 is going to make this into a seconds as it is already divided by second. So because of that, this 60 will come to the denominator, not to the numerator. And then further, this ml can also be expressed as a centimeter cube, right? We all know that 1 ml is nothing but the 1 centimeter cube, like this is the cube like structure, right? So if the length of each side is 1 centimeter, then this is called as the 1 ml. So 1 ml can be expressed as a centimeter cube. Now there is an intention behind this expression. So let us now understand the calculation of A first, and then I will explain why this conversion matters. So A is nothing but the cross-sectional area of the column, and this can be expressed as a pi into r square. But most of the times this r is not available in case of the column dimension. The column dimensions we always have a inner diameter, and this inner diameter can be used to measure the r. So r is nothing but what? If d is the inner diameter, then r is equal to d by 2. So if you substitute this r into this calculation formula, you come across this equation, pi into d by 2 square. Now here is a small error, that this millimeter has to be read as a centimeter. Okay, so please take care of this. And then further, if I substitute this value of A into this equation, I come across this one now. So this is a quite complex equation, and we will try to simplify this equation further. So now I have replaced pi by 20 by 7 because we all know the value of pi is 20 by 7. And now I can further simplify this equation, and once I calculate this, I get a factor of 0.0212. So let me further state the exact calculation formula for a linear velocity. So this is the final calculation formula. Flow, 0.0212 into flow in terms of ml per minute divided by diameter square, and diameter is expressed in the centimeter. So let us take one example to calculate the linear velocity. So this is the example. So you have a flow rate in 4 ml per minute. We have a inner diameter of the column is 0.46 mm. Now we know the calculation formula over here. So once you substitute the values, but before that, the unit of diameter must be centimeter. So the first and foremost, we will convert this inner diameter from millimeter to centimeter, thus by dividing 10. So we get 0.046 centimeter as a inner diameter. Then substitute the values, and you can easily calculate the value of, oh, this is the type error, read this as just centimeter. So the 40.07 centimeter per second is the linear velocity if the flow rate is 4 ml per minute. So I hope you understand how flow rate can be converted into a linear velocity. Do subscribe to this channel and do share this video with your colleagues and friends. Thank you so much.